it's time for some integration part. So this is question number 6 from same 74 Choitra. So we have got this integration. So we'll solve it. How we solve it? Solution: y is equal to, let y is equal to integration from -1 to 1 upon x square dx is equal to, first we -1 to 0 1 upon x square dx plus 0 to 1 upon x square of dx is equal to limit as tends to 0. Why? Because when we put the value of 0, it will be indeterminate. In 1 upon 0 it would be infinitive. So we put limit s tends to 0, and when we put h, it will not be infinity form. Now from here 0 0 -1 to 0 to minus h 1 upon x square dx plus 0 plus h2. Your limit is missing, so limit h dash tends to 0 plus h2 1 upon x square dx. Now limit h tends to 0 and derivative of this is -1 upon x -1 to minus h, and derivative of this limit h dash tends to 0 -1 upon x h2 1 is equal to now we can put the value limit h tends to 0 -1 upon minus h, it will be plus h minus 1. For the value it will be 1 plus limit h dash tends to 0, and it would be minus of 1, and minus would be plus 1 upon h. For dash it will be h dash, it will be h dash, so h dash. So when we put the value of h here, it would be 1 upon 0 form, so the limit does not exist. So the limit does not exist, that is integration is not possible here. But for principal value put h is equal to h dash, we get -1 to 1 upon x square dx is equal to, derivative is -1 upon x -1 to 1 is equal to -1 is equal to -2. Answer. Now we move to our next question. It is question number 7, which is asked apply the rule of differential under integral sign to evaluate 0 to infinity equal power minus ax sin x by x dx, and hence deduce. Also it is asked, you can see the question for it. So we do solution. What we do, it is in the form, this looks like a standard form. So we first it is asking under integral sign, so we do it under integral sign. First we differentiate with respect to a, with respect to a we get let y is equal to this, and from 0 to infinity with respect to a x minus x e to the power minus ax sin x by x dx is equal to, this is cancelled from 0 to infinity, minus e to the power minus ax sin x dx. Also we know what we know. We know that integration from 0 to infinity e to the power minus ax sin bx is equal to b by a square plus b square. So what we can write, e in 0 to infinity minus e to the power minus ax sin bx is equal to minus 1 upon 1 plus a square. So we can write this on integrating what we'll get. On integrating we'll get I or y is equal to what, minus 1 upon 2 log of, or 1 upon 1 plus a square. It is tan inverse x plus c. It is tan inverse x plus c. So when this is equation 2, let this be equation 1. When a is equal to infinity, a is equal to, or what we put the value, there is tan inverse a, and when a is equal to infinity, then from in equation 1 what we have, then we get y is equal to 0, and in equation 2 when this is there, then we get y as 0, y is equal to c minus tan inverse of infinity with pi by 2. So we get the value of c is pi by 2. We get the value of c is pi by 2. So what we do the value of c here. So y is equal to pi by 2 minus tan inverse of a, and this is cot inverse of a, and this is our answer. Next question is asked to deduce 0 to infinity e sin x by x dx is equal to pi by 2. Put a is equal to minus, a is equal to 0 in equation 1, then we get 0 to infinity sin x by x is equal to cot inverse of 0. This is pi by 2, proved. Now we move to our next question, that is question number 8. Question is asked define beta function. Question is asked define beta function. How do we define beta function? We define beta function as beta function the integral 0 to infinity x to the power m1 minus x to the power of m and 1 minus x to the power of m minus 1 minus x to the power n minus 1 dx where m is greater than 0, comma n is greater than 0 is called beta function. That is given by, it is given by beta of m comma n is equal to 0 to infinity x raised to the power m minus 1 minus x raised to the power of 1 minus x dx when m is greater than 0 and n is greater than 0. The next attached question is asked with set evaluate let y is equal to 0 to 2a x to the power of 5 root over of 2ax minus x square of dx. We solve for this solution. What we do, we put the value of x is, and we put the value of x is 2a sine square x, then we get dx is equal to 2a into 2 sine x cos x. We get this, and 2 cos, we put this theta and theta d theta, get this value. Now we put the value I is equal to x raised to power 5 0 to 2a, and when x tends to 0 to 2a, this is the limit, our theta tends to 0 to 0. When this is 0, then 0, then when this is 2a, our theta tends to pi by 2. So 0 to pi by 2 is our limit, and x is 2a sine square x 5, and this 2a it is 4a square, 4a square sine square, this is same, so it is maybe taken out as 2a sine x, and inside it remains 1 minus sine square x with its cos square x, and when it comes out it becomes cos x into dx. What is our dx? 2a into 2 sine theta cos theta d theta is equal to 0 to pi by 2. How many 2 are there? 5 6 7 8. 2 raised to the power of 8. How many a are there? 5 6 7. A raised to the power of 7. And how many sine are there? 5 to 10 11 12 sine raised to the power of 12x. And how many cos are there? There are 1 2 cos raised to the power of 2. Sorry, this is theta, you maintain here also theta. What is theta? Here also it is theta. You can make it yourself. Is equal to, now 2 to the power of 8 and 8 raised to the power 7 comes out. Now this we use the formula of 1 upon 2 to 12 plus 1 12 plus 1 by 2 to 2 plus 1 by 2 by to 12 plus 2 14 plus 2 is 4, or 12 plus 2 plus 2 by 2. Now when we solve this, what we get? We will get 2 raised to the power of 8, a raised to the upon 2, and this will be our 11 by 2, that is 11 by 2. We can write to 11 by 2 as 11 9 by 2 into 9 by 2 7 by 2 5 by 2 3 by 2 1 by 2, and to 3 by 2 can be written as 1 by 2, and root pi from both it gives pi. and here 12, 2 and 2, it makes up 16. 16 by 2 is 8. 7, 6, 5, 4, 3, 2, 1. That is 8 is factorial of 7. That is formula, and we can cancel 7, 5, 3, 5, 3, and how many 2 we can cancel? We may cancel all. 2 raised to the power 8. So 1, 2, 3, 4, 5, 6, 7 and 8. Now what we have remaining? We have remaining this 3, 2 is 6, 3 is 9. 3 is 9. What I have remaining at the upper side? 2, 3, 8 raised to the power of 7 by 4 into 2 is 8. And anything remaining on the topmost side? I don't think anything is remaining. I think all are done for a good. 4 into 2, 8. It's 8. I hope it is 8. Here 12 plus 1, 13 by 2, so 11 by 2 is missing. 5 is there, 11 by 2 is missing. So what we do? 11 by 2 is missing, so 1, 2 is there. 2 into 2 into 4, 11 into 3 will be 33. So word answer 4 to the 8 to 8 is 16 into 7. 4. Oh, this 7 is cancelled, so 4 is 8 to the 16 by 16, and here pi. This pi is our answer. And this was our question number 8 from alpha beta function. Now question number 9 is remained. This is the question asked. Given circle r is equal to a and choroid r is equal to a cos theta is given, and common area is asked. Common area is asked. So first we make the figure. How does this look like? This is the circle r is equal to a with radius a, and our choroid would be this. Would be our choroid. This would be our choroid passing through this point. This is our choroid, and we have to find only the overlapped area. So from this point to this point it is circle, from this to this it is circle, and from there to here only choroid part is set. So we add this part and this part from circle and this part from choroid. So this is 0, this is pi by 2, this is pi, and this is 3 pi by 2. So what do? We do from 0 to pi by 2 for circle and pi by 2 to pi for choroid, and multiply by it, we get both side result. So area is equal to, we get 0 to pi by 2 for circle. Area of circle 1 by 2 r square, 1 by 2 r square d theta, and we multiply by 2 for both, and for plus for choroid it is from pi by 2 to pi, and the equation is 1 upon 2 a square 1 plus cos is cos theta. Now what do we do? Now we just integrate it. That is 1 by 2 is common, that will be 2 will be cancelled. So we do 0 to pi by 2 r square d theta plus pi by 2 to pi a square. We open the formula, and it would be 1 plus 2 cos theta plus cos square of theta d theta. Then it will be r square. r square is a, or r square can be taken out. We take out r square is a square, a is square and theta, that is this we directly integrate, it becomes our theta from 0 to pi by 2, not for confusion, pi by 2 to pi a square 1 plus 2 cos theta, change this cos square theta to cos 2 theta, 1 plus cos 2 theta by 2 d theta. Now we will integrate this pi by 2 minus 0 is pi by 2 plus this a square, it comes out, and what now we can do 1 from pi by 2 to pi, pi by 2 to pi, it is pi minus pi by 2 plus 2 cos theta, derivative of 2 cos theta is 2 in antiderivative of 2 cos theta is, or integration of 2 cos theta is 2 sin theta, so 2 sin theta, sin pi is 0 and sin pi by 2, it is sin pi by 2 is 1, sin pi by 2 it is 1. Now what we do, or here is minus because it's minus, and plus 1 by 2, this 1 by 2 and 1, integration of 1 is pi minus pi by 2 for this 1. Now for cos 2 theta, a is cos 2 theta, derivative of cos 2 theta, and the derivative of cos 2 theta would be 1 upon 2 sin 2 theta, and sin 2 pi is 0 and sin 2 pi by 2 is also 0, so this whole term would lead to 0. Now what we do, we have a square is common, so we take a square common, and here what we have, the remaining a by 2 plus pi minus pi by 2 plus, or this would be minus 2 minus of 2 plus, this would be pi by 2 minus pi by 4, now pi by 2 and pi by 2 cancel, and now remained a square, and what other are remained in the, and this take LCM is 4, and this will be 4 pi plus 2 pi minus pi by 4 minus 2, and this would be our a square by a square, this would be 5 pi by 4 minus 2, and this would be our area answer. And this concludes our integration. It was up to volume and surface area. This was the format for integration.